Welcome to Milestone 6. In this milestone we're going to look at the TACE beta environment emulator and see how that improves on the TACE alpha environment emulator. The beta environment emulator adds a number of microprocessors. It's the peer communication unit, which is new, slow memory microprocessor, the set memory microprocessor, and the fast memory microprocessor. If you just take a look at this diagram, you can see that. Now the BI3 TACE beta environment emulator improves on a number of features, and these are resolved. You can see in this diagram over here that most of these are resolved in the TACE specification itself, but a number of them are actually resolved in the emulator, particularly the SOA, which is, if you remember from the previous milestone, that is a static array that's stored once and can be cached. The BI3 TACE beta environment emulator resolves this into slow memory and fast memory. So there are two SOA types that are specified in the specification. Now I'm going to talk about those various microprocessors and the functionality that they convey. Essentially, the slow memory microprocessor is used to store large files such as video or sound, and these files are stored probably in a hard drive. Slow memory is designed to move large chunks of information from permanent storage, but as the name implies, the bandwidth is not very good. The fast memory microprocessor, on the other hand, is designed to move large amounts of memory from random access memory and the fast memory into the CPU, and can be used for displaying objects and network as well. The fast memory differs in the sense that it doesn't store information permanently and is limited to the size of the memory store, where slow memory is designed for large files and is probably designed for hard drive access. Of course, we don't know the exact implementation, so the BI3 specification doesn't specify that it has to be a hard drive that stores that slow memory or fast memory, but the hard drive is most likely to be that device that's used for slow memory, and fast memory is most likely to be implemented in memory. The fast memory and slow memory primitives are used to access data off these microprocessors, and you can see from the classes of the fast memory and slow memory descriptions that there's a number of methods that are used to access information from those microprocessors. Now if we just take a look at fast memory for a second, we'll see that we can essentially create a fast memory by using arrays. So the fast memory is essentially built to operate directly from memory. I'm not going to spend too much time actually looking at those method calls. What we're trying to show here is that the BI3 specification describes an actual implementation and is much more concrete than TACE. I'm now going to talk about a flow junction. A flow junction is a primitive that allows you to set up a connection between any two processes. You can't actually send information across a flow junction, it just represents the path. And a flow junction relates to a sealed duplex in TACE. In order to derive an unsealed duplex, so that you can transmit data, you're going to need to use a flow, and you can derive a flow from a flow junction using the unseal flow method in the flow junction. It's best that you study TACE and understand clearly how the sealed and unsealed duplexes work, because they're a complex primitive type. But the flow junction and flow are the direct implementations of that in the BI3. Now the BI3 emulator has the set memory microprocessor which stores all the sets, and if you look at this diagram here, you'll see that the set memory is a very basic structure where each agent has its own memory, and the set parameter is included inside that. The set itself has a number of methods that allow you to manipulate the information inside it, so you can see the BI3 emulator is extremely specific here, and you can insert children, you can set all the other primitives using those direct access methods. And of course the BI3 is booted with a set parameter, and here's a diagram over here showing how that occurs, and the execute primitive is directly attached to that set. Any other parameters are included inside that set. I'm now going to talk about the Milestone 6 itself. If you look in this diagram here, you'll see that we have two TACE beta environment emulators running in parallel, and they're connected with a flow junction. A flow junction is similar to a sealed duplex. You of course need to unseal it to make it operate, and that flow junction was passed in on boot out for both of those agents as the set parameter. So they begin communicating straight away, and you can see from this code in agent A that it unpacks the flow junction from the parameter set, opens it up, unseals it, and begins transmitting information across, and then destroys itself, and agent B then receives that data and stores it. So good luck with trying to figure out what that code does, and have a look at that specification. Thanks for your attention on Milestone 6.